All right, let's do the review. So, first question is parametric equation. They're basically in order on the actual test is the same as I just literally changed some numbers here and there. You're allowed your one index card for this test, so you'll have that. Your final exam next week, you're allowed the sheet of paper. So nothing drastic. Scott passed out index cards, or at least dropped them on the edge of the table for you. So you can just use the 4 index cards if you want for your actual final exam. That's fine. It comes out to be about the sheet of paper, so that's why I did it that way. All right, so the first one is a parametric problem. The first thing we have to look for is the tangent line at a point. So to find tangent lines, I need to find the derivative. So let's find the derivative of this. So we've got dy over dx. So for parametric, it's dy dt over dx dt. So in this case, I've got the derivative of y, which is 3t squared, over the derivative of x, which is 2t. So dy dx is 3/2 t. Now, they gave us a point. So the point was at 1/4 and 1/8. That's x and y, not t. I need to find t that would give me that. So the nice thing is I made this pretty simple. Like I picked one that would work. You should be able to figure it out. So what raised to the 1/2 is going to give me 1/4? I mean, what raised to the squared was going to give me 1/4, which is 1/2. And then you just test it the other one, 1/2 to the 3rd power is 1/8. T. So now I can plug that in here. So my derivative at that point is 3/4. Because it's 3/2 times 1/2. And now to find my tangent line, I can just use the point slope equation. So I have y minus 1/8 equals 3/4 x minus 1/4. And you can leave it like that if you want. That's fine. If you want to change it to slope-intercept form, you can, but you can leave it as a point slope equation.
Oh, you want us to try to like reduce it down more?
No, you can leave. So there's 3 main ways that you can write linear equations. You have the slope-intercept, which is the form that most places use. You have the standard form, which is ax plus by equals c, and point slope form. So that's one of the valid forms. And for this one, it's work. So, pleasure. Let's wait for the second one. All right. So that's my tangent. Next thing we have to find is I'm going to find my area under the curve. If I can actually get this to work. There we go. That's what I want. So what's the formula for area under the curve for parametric?
Integral of y times dx over
Y dx plus dy squared plus square root of it.
No, that's arc length.
Oh.
It should be just y dx. If I remember my formula correctly. So in this situation, when we do it, you have your it's literally just the derivative of the x term and the y term. So I'm just making sure that I got the equation right. I'm not missing any little piece of it. Yep, just y dx. Oh, from the actual range. So in this case, it's from 0 to 1. So in this case, I've got the y, which is, so we're going from 0 to 1. So I have t to the third power times the derivative of x, which is 2t dt. So we have, there go from 0 to 1 of 2t to the fourth power. Remember integration, add 1, divide. So I have 2/5 t to the fifth, and we're evaluating this from 0 to 1. So this comes out to be 2/5. The derivative of x. So x was 2 t squared. Derivative of that's just 2t, and then times the derivative of whatever t is. That's where the dt comes from.
Yeah.
So in essence, it's the chain, the u substitution rule, or sorry, not that. It's the implicit differentiation. What? Gotcha. All right. The next one. I'll let you finish writing that down. So we've got the surface area rotated around the x-axis. There was no point in me having you guys find the arc length, because to do the surface area, you've got to use arc length anyway. So just two birds, one stone. We're rotating this around the x-axis. And we're still doing it from the 0 to 1. So here's my formula for it. So we've got the integral from 0 to 1 of 2 pi times y, which is t to the third. And then we have the derivative of x, 2t squared, plus the derivative of y, 3t squared, dt. So we've got 4t squared plus 9t to the fourth. I don't think we can do that. I don't think we can factor this one, but let me just check. Hold on. Try something real quick. So I don't think it's gonna help. Because use maybe no. All right, so we can't break down the square root there. So Desmos it is. So just remember when you're using Desmos to do x's. We've got 2 pi x to the third square root or x squared sine x to the fourth. So we get, so the surface area when it's rotated around it is 4.04.
So with y, we're on the y-axis, we would just change the y to an average from the.
Yeah. It's literally the only change. No, the y. If you're going on the x-axis, if you're going on the y-axis, you do x instead of y. Yeah, see where it's 2 pi y? You'd use the x. That right there. Because remember, that's telling you, so that's telling you the radius. So since the radius is from the x up, it's the y curve that's telling you that. If it's going the other direction, you'd be doing the x for it. So that'd be the x.
The A and B doesn't matter. It's like
Right. Those are the t's. So, because everything ends up being in terms of t, because the y you're replacing with that, or the x replaced with that, the derivatives are going to become out to dt. So it's in dt. So you're that 0 and 1's based on the t.
so the range, sorry, I think I have to, so it's the 0 and the 1 and the original.
Yeah.
Okay.
Yeah. All right. Polar. All right. So in this case, let me just do this way. So I don't have to copy it. We're looking for tangent for this one when theta is pi over 2. So we need our formula. So this is my, really? Trying to copy a piece and it's not letting me. Fine. I just didn't feel like writing it all out again. I know, it really is. So there's our derivative. So my r is 2 sine theta. My dr d theta is the derivative of that. So it's going to be 2 cosine theta. So when we plug it all in, we have 2 cosine theta sine theta plus 2 sine theta cosine theta over 2 cosine theta cosine theta minus 2 sine theta sine theta. Now, you don't have to simplify that down because you've got your theta. Theta is pi over 2. So cosine is going to be 0. Sine is 1, 1, 0, 0, 0, 1, 1. So this ends up being 0 over negative 2, which is 0. So my slope is 0.
Here, theta.
Because the derivative of sine is cosine. And the 2 doesn't matter because the 2 is outside of it. So we now have to come up with the point on where this is on the graph. So if we plugged in theta to, or pi over 2 to that, we get 2. So y equals 2 because my slope is 0. And actually, if you looked at this graph, that's the other thing. When you're doing these, graph them and see what they look like. Because this one's just a circle. It helps you verify your answers. So you can see, well, yeah, that's a horizontal asymptote right there. So the tangent's going to be y equals 2. All right, next part, area under the curve. The area under the curve formula for polar is the area from A to B, or the integral from A to B of 1/2 r squared d theta. So we can pull the 1/2 out. So the integral is going from 0 to pi of 2 sine theta squared d theta. We can then pull out the 4, basically. So we're going to have 2 left in front, 0 to pi of sine squared theta d theta. What is the, so we have to do that half angle rule. So it's 1/2. Is it 1 minus or plus? This 2? So 2 squared is 4. So if I pulled the 4 out, 4 times a half is 2. 2 theta. Hold on. I just want to make sure I'm using the right cosine. because I can never remember if it's the plus or the minus one. Minus. Okay. So we now can pull out the half. So this ends up becoming 0 to pi of 1 minus cosine 2 theta. 2 theta. So this goes to theta minus 1/2 cosine integral goes to sine 2 theta. And we're evaluating this from 0 to pi. So this comes out to be pi, because sine of 2 pi is 0. And again, if you looked at your circle, it's pi r squared. The radius is 1. The area's got to be pi. All right. Next one, arc lengths. What should the arc length be? Before we're doing it, what should the arc length be? 2 pi r and r is 1, so it's 2 pi. So the answer should be 2 pi. All right. So we're doing it from 0 to pi. We have 2 sine theta squared plus 2 cosine theta squared. So just working inside the square root, I have 4 sine theta plus 4 cosine squared theta. So I have 4 times sine squared theta plus cosine squared theta, which is just 4. So the square root of 4 is 2. So this whole integral comes down to 2 d theta, which is 2 theta, which is 2 pi. Exactly what we should have done. If you write 2 pi in your paper, I'm not giving you credit for it, though. You have to show me the work. All right, questions with that? Next one. So we're looking for, in this case, we're looking for the tension vectors for these. All right, so we have our, this is a 400-pound beam, so 400 pounds. We have T1 and T2. So those are my two vectors. Okay. So this is actually the opposite of the problem that we did in class. So it's, if we were to literally spin this around, or I can't spin the picture around. We had the bar at the top and the weight pulling down. It's the same concept. So I'm basically looking at so how much it's pulling. So T1, if I can get this right. So we're, how much are we pulling? So there's my angle. And I know that's 60 degrees. So we have T1, the magnitude of T1 times, for the X is cosine, 60 degrees. I, and then it's plus T1, and to find the other side, it's sine 60 degrees, oh, sorry, minus of J. And it's minus because it's down.
Sine 60J, right?
Yes. Oh, actually, it's going to be minus that side too, that direction. $60I, and then minus T2 sine 60J. So we've got, if that's my 0, it's basically in the middle. That's negative on the I, that's negative on the J. That's positive on the I, that's negative on the J. They're negative for the J. The Y. The Y is negative. It's positive on the, so T2.
Why is T1?
Because we're going, it's going,
T2.
it doesn't make a difference which one you make, honestly. It's not going to matter. I labeled this one as T1, so this direction is going to be the negative if that's my middle. Yeah, so it's like if that's that's my x and my y, that's 0. This is the negative side. That's the positive side. And then in the end, it actually doesn't make much of a difference which one you make negative. One of them's got to be negative, one's got to be positive because they're in opposite directions. So that's the only thing that matters. If you put the T2 on one side, T2 on the other side, that would have changed. It wouldn't have made a difference. All right. So now we can add these two equations together. So T1 plus T2 equals -2 negative T1 sine. I need to move my thing. I'm never going to finish writing that whole statement there. All right, so first one we have is T1 plus T2 equals -400 pounds. So pulling it down. Sorry. Negative weight, which ends up being 400 pounds. The opposite direction. And since it's in the down position, that's 400 J. Okay. That part makes sense. So we've got to have the two things. Our weight going down is 400 pounds, so it's 400 J. All right. So if we look at our I and our J, so we're just going to look at the I's, which ends up being 0, and the J's, which ends up being 400. So we have negative T1 cosine 60 plus T2 cosine 60 equals 0. And then we have negative T2 or T1 sine 60 plus minus T2 sine 60 equals 400. So we can solve the first one. So if we take this first one right here, I can solve it for T2. So T2 equals T1 cosine 60 over cosine of 60. So T2 equals T1. And if you look at the picture, totally makes sense. They're 60 degrees. They're going to be exactly the same magnitude. They're just going in. We just have to figure out the actual locations at the end. So I can replace T2 with T1 or vice versa. So I can take this statement here. So I can now change that to -2 T1 sine 60 equals 400. And I messed up my, well, actually, I didn't mess up my because it's going down. So the magnitude of T1 sine 60 equals negative 200. So we're divide that negative 200 by the sine of 60. The sine of 60 is square root of 3 over 2. Yeah. I'm doing my unit circle quickly in my head, and I'm going to totally mess it up. Yeah, square root of 3 over 2. So it's negative 200 divided by the square root of 3 over 2. So we've got negative 400 divided by the square root of 3, which we have to use a calculator for. Comes out to be negative 230.9. So my magnitude is negative 230.9. And remember, all that does is reverse things, so it actually doesn't make a difference if it's positive or negative. It will still come out to be the exact same thing, just going the opposite direction. So you're still going to have the same two things. So we go back to my initial two problems. And now we plug everything. So T1 is negative 230.9 times 1/2 I minus plus 230.9 times square root of 3 over 2 J. And T2 is negative 230.9. Or actually, I was using the positive version of it, isn't I? So that's minus. That's positive. 1/2 I minus 230.9 square root of 3 over 2 J. And you can leave it like that. You don't have to simplify that. So you want to get it to full decimal, you can at that point. But. And if I remember right, okay. Nothing drastically different on that problem on the actual test. So. No. I have done that in the past, actually, but not this time. I made a slight change to the number of the problem. Yeah. Yeah. So instead of 400 pounds, it's a different weight. The rest of the stuff basically stays the same. All right. And again, just looking at like, when you look at the picture, it's your goal is to make sure that it makes sense for the problem. So if this vector has got to have a negative I and a negative J, that vector has to have a positive I and a negative J. So as long as that works out, you're fine. So it's like, that's like, use the pictures to help you do the stuff. All right, dot product. So in this case, we're looking for the angle between these two vectors. So what was the formula for angle?
Cosine theta, A dot B times the A times the sine.
Magnitude.
For you, is that just one for?
It's an I. When I hit space on Word, it capitalized the I.
Oh,
You know, I have one, I'm like, yeah,
Yeah,
one is
it,
pretty good,
that's one
yeah, it capitalized the I on me. Now I have to check the actual test. The test did the same, by the way.
So you'll be lenient on that question.
Now I'll write it on the board to remind you of it.
Literally zero one, like, one minus three.
Yeah. Yeah. It's an I.
I was about to be zero.
You know the difference is, so like on my computer at home, I've basically turned off almost all autocorrect on Word, because with the book we're doing certain things and having to write certain ways, and autocorrect totally screws things up. On my laptop I haven't. So it autocorrected on me. All right, so we have to find the dot product and we have to find the magnitudes. So yes. So huh? Oh, the test will be the same, just different numbers. Yeah, all I literally did was change numbers, so, which is pretty much all I've done for all of my tests. Yeah, just, I'm just going to make it fourth dimension. I'm going to add the fourth dimension to it. All right, let's find A dot B first. We'll do the dot product first. Huh? It'd be time.
I thought we already do it.
All right. So we have 1 times -2 plus -3 times 1 plus 2 times 4. So -2 minus 3 plus 8. So my dot product is 3. Now I find the magnitude of A. So 1 squared plus 3 squared plus 2 squared. Remember, it's squared, so the signs always are positive. So I just didn't feel like put my parentheses on this one. So I've got 1, 10, 14, so the square root of 14. And B is 2 squared plus 1 squared plus 4 squared. So 4 plus 1 is 5 plus 16 is 21. So the square root of 21. So I have cosine of theta equals 3 over square root of 14, square root of 21. Since you have to do this as an arc sine anyway, I wouldn't go through and deal with simplifying down the square roots because you're going to have to put in a decimal sign anyway to do the arc sine. So I would just go to Desmos and type it in like that. So arc cosine of 3 divided by 15. So I typed it in literally just like that. So we get 79.9. So the angle is 79.9 degrees. And when you're looking for the angles for these, you want it in degrees, not radians. All right. Oh no, that was on the final exam. I did that. I was like, wait a second. I thought I'd give you the formula for one of them. That's the final exam problem. All right. So this one we're using the scalar triple product to determine whether the points lie in the same plane. So if I do a scalar triple product, the points, if they lie in the same plane, it should equal what? 0. All right. So if I do the scalar triple product and it comes out to be 0, we're good. When you're doing these though, and there should be a D there, you need vectors, not points. Okay. So we're going to find vector AB, vector AC, and vector AD. Okay, so the first step you have to do is we have to find the 3 vectors. You can't just use the points. It actually does not matter which ones you use and which way you set up your vectors. You just have to have it as 3 vectors. Okay. It's D. It's point D. I forgot the D. Okay. So if you wanted to use B as your point and do them from there, it's fine. Because if they are all in the same plane, it doesn't make a difference which ones it is. And if they're not all in the same plane, again, it doesn't make a difference. It's going to be off anyway. Okay. So let's find our vectors. So my first one, so we've got -1 minus 3 is -4. 2 minus 0 is 2, and 5 minus 2 is 3. Next vector, 5 minus 3 is 2. 1 minus 0 is 1. -1 minus 2 is -3. And last one, -3, 4, and 0. Now we just set it up in terms of our matrices. So we're going to do -4 times 1, -3, 4, 0, minus 2, 2, -3, -3, 0, and then plus 3, 2, 1, -3, 4. Remember, it's plus minus plus. In this case, it's -4 because it's -4 there. All right. So we've got 1 minus -12 times -4 minus 2, oh, not 1, 0. 0 times -9. And then 8 minus a -3. So we got -48, positive 18, and positive 33. Doesn't equal 0. So -30 plus 33 is 3. So they are not propylene.
You know.
Yeah, let me just let people finish writing this down and then I'll switch back. Okay. That's your test. Should you be able to finish it in 2 hours? Okay. Huh? 5 questions. So the way I'm scoring it, it's going to be out of 12 questions. So the first 2 are the 3 each, and each of the other ones are 2 points or 2 each is the weighting. So the first couple will be weighted a little bit more because there's more parts to it. So basically, your first 2 questions are half the test. Your last 3 questions are half the test, which balances it out. Chapter 10, chapter 12. So. Okay. Yeah. There you go. I'll be here at 4.